Lesson 7.5. We're going to get going on that. Lesson 7.5. The first thing I'm going to do is come over to our Google Classroom. I'm going to open up just a couple documents. Today we will use the Desmos pre-programmed graph, so I'd recommend you go ahead and click that. I'm going to have quite a few where today is the lesson itself is built on using graphing tools. So you need to open this up. Even if you prefer algebra, you still need to open this up for today. And not only that, I'm going to be using the formula chart exclusively on the bellringer. I will use the formula chart, that is to say. So on the bellringer, we got 3 problems here. We're going to be talking about writing an equation because that's really what the TEKS say that the pre-calculus student will be able to do is graph these different shapes given key attributes or characteristics. So number 1 here. Let's take a look. It says write the equation of a parabola. So that's what I'm going to do here. Write the equation of a parabola. So I'm going to first draw your attention to on the formula chart that for the parabola, let me find that parabola. Here it is. And really all 4 shapes here, circles, parabolas, ellipse, hyperbolas, the formula, whether you're looking at the horizontal or the vertical formula all the way down your list, the only thing that's different on any of the formulas is where the y minus k and the x minus h are located. That's the only thing that will change position with one another. Everything else is basic. So what I'm going to do here is to copy down what I know is true of a parabola. And that's you'll have a parenthesis squared equals 4p times another parenthesis. As we've learned the last few classes, what's required of you to solve one of these problems from here is knowing your vocabulary and just plotting the few points that they give us. Actually, this one, they don't even give us, they gave us 1 point, but not multiple. So I'm actually not going to do that on this problem. It says here, the directrix is x equals 4. So again, if you wanted to see where that would be, that's on the x-axis, 4 units to the right, and it would be a vertical line. So you'd go 4 units to the right, and you'd have a vertical line. That's what that would look like. But you actually don't need to do that on this particular problem, but there it is anyways. What could I do? Well, if I go to the formula chart and I see directrix here, notice I have 2 different formulas for directrix. I have x equals a value and y equals that same value. Well, no, I'm sorry. H and k are separate, but we have x equals something or y equals something. On our problem, what were we given? X equals 4. What that means is that we're using the formulas that are on the left side. So now I know where y minus k is located and the x minus h. So y minus k is located here and x minus h is located there. We also can establish that even though our problem said that the directrix is x equals 4, the formula chart said that x would equal, for the directrix, x would equal h minus p. I'm going to write that down here for a second. Now we're also given this focus value. It says the focus is located at -2, -5. So that would be left 2, down 5. 1, 2, 3, 4, 5. And so this would be my focus. So if you wanted to, you could start solving things going off the distance change from here to here, that's 6 units. We can find out that the vertex would be halfway through there, so on and so forth. So you could use the graph if you wanted to. On this one, you could also use algebra because focus is one of the values that's listed on the formula chart. So you can actually just use you don't even have to use your distances and spatial awareness to solve this problem. You could actually just solve it saying, okay, the focus is h plus p, comma k. So h plus p comma k is what I'm going to write down next. H plus p comma k. This is the formula chart right here. This is what they gave us, the given. And so what I can determine from here is that number 1, -5 is my k value. So when I go to substitute this in, I would have y minus, I take out k and replace it with a -5. So it's y minus a -5. Is there a cleaner way of writing y minus a -5? Yeah, I could just say that's y plus 5. And then I can see that 4 equals h minus p if I do a substitution there. If x is 4, I can just plug the 4 right there. So 4 equals h minus p. I can also say that negative 2 equals h plus p. I can solve this using the old algebra technique called elimination. If I combine these two equations together, we can find out that 4 minus 2 is 2. So 2 would equal h plus h is 2 h's. Negative p plus a positive p. Eliminate each other. So 2 equals 2h. And if I want to isolate that h for my formula, that 2 is multiplying. What is the opposite operation of multiplying by 2?
Dividing.
We could divide by 2. And we could find out, okay, h is equal to 2 divided by 2, which is 1. So now I can come up and substitute that in. So this h gets removed, and in its place is a 1. Now, when you look at these points, you'll notice why we say so frequently inside lies. It's because we have the location of the vertex being a right 1 unit, but when we put it again into the parentheses, it looks like x minus 1. It looks like a lie. So that's why we say that. We're left with one thing left to do. We need to solve for p. I would suggest pulling either one of these two equations to solve for p. Now that we know h, we just plug it in. I'll take this bottom one right here. I think this one would be the easiest personally. And so I'm going to say, instead of h, I'll say 1 plus p. So negative 2 is 1 plus p. How do I isolate this p? We subtract 1. And so 2 minus 1, excuse me, negative 2 minus 1 is negative 3. So negative 3 equals p. That's what I was talking about, that the focus is 3 units away. And the reason it's negative is because this graph would open around our focus this direction where it opens left. So the p is negative, meaning it's opening to the left. 3 either way. That's visually what that meant. The formula wants 4p. So what would be 4 times that negative 3? What would that equal? Negative 12. And that would be the answer to number 1. Quick review. If you want to draw this perfectly accurate, the width here, if you're wondering why does the equation have 4p? Well, mathematically, that's the way it works out. But as it turns out, there's something else special about this. The distance across the focus here is called the lattice rectum. That length is always the absolute value of that number. So if you drew it perfectly, this would need to be 12 units wide. Isn't that neat? So that would have to be 12 units wide if it was drawn perfectly. So I don't think I drew mine accurately. I think it would need to be much wider to get it to be, it need to be 6 up and 6 down from that focus to get it right. All right, part 2. It says, write an equation of an ellipse. So I'm going to pause and do the same thing I did first on the last problem. So to write an equation, I'm going to copy down what is common in both ellipse formulas, both the horizontal and the vertical, which happens to be everything but the x minus h's and the y minus k. Everything else is the same. So what did the formula look like? It was a parenthesis squared divided by a squared plus another parenthesis squared divided by b squared, all that equaling 1. The part that alternates is this equation going to have, excuse me, this fraction going to have the x minus h in the numerator, and this one have the y minus k, or is it going to be vice versa? That's the part that alternates. So to determine that, we need to know some vocabulary. It's going to say co-vertices. What should we associate co-vertices with? It's either 2a, 2b, or 2c. 2b is correct. It's 2b. So the other words for co-vertices from on an ellipse, the minor axis goes from co-vertice to co-vertice, or co-vertex to co-vertex. So you could call that 2b. And if it were a hyperbola, you would call that the conjugate axis. So those are other words that mean you would solve the same way. So if I pull out a graph real quick, if we went left 1, down 3, left 1, down 3, we would have this point here. That's a co-vertex. And it says left 5 down 3. Left 1, 2, 3, 4, 5 down 3. There's my other co-vertex. Great, there's my points. To solve this, we would need to calculate the distance between these 2 points. So this co-vertex is left 1 unit. This co-vertex is left 5 units, but we only want the distance between them. So what's the difference between being left 1 and being left 5? How many units apart are those? 4. They're 4 units apart. That means 2b equals 4. Now something that's very important about this is we are connecting that our co-vertices deal with the letter b, just like this fraction here deals with the letter with b squared. Since this is moving left and right along the x-axis, left and right, that means my parentheses in the numerator is going to have the x minus h on this one. Why? Because it's moving left and right here, and these 2 points move left and right of one another, horizontal. And so the b, since they're connected with the variable b, and the b fraction, I call it the b fraction as the b squared, I need to move it horizontally. That means the x minus h. That leaves us with y minus k over here. Are you okay with what I've done there? How I made that observation? Okay, so now let's find the center. If 2b equals 4, to find the center, let's solve for 1b. What does 1b equal? 1b would equal 2, and you could plug this in. B squared would have to equal 4. I'm going to go back to that 1b in a second here. If 1b equals 2, that means the center is 2 units away. So I'm going to go to the middle. It's 1, 2, right there. That's our center location. It would be left 3, down 3. Left 3, down 3 would be the center. Left 3, down 3. So we can plug those in. Again, they're going to look like lies because it's going to be a minus a negative 3 and a minus a negative 3. So it's going to turn into a positive 3 and a positive 3. So now we have all that done just off the co-vertices. So we come back and say, all right, this problem has foci. What's the formula for foci? 2a, 2b, or 2c? This is 2c. So left 2, left 3, up 2. Here's a foci. And left 3, down 8. So 4, 5, 6, 7, 8. Here's my other foci. Down 8. This foci is 2 units up. This one is 8 units down. We're doing total distance. So 2 plus 8 is how many? 2 plus 8 is 10. And if we solve for c, we would find out that c equals 5. Okay, now that doesn't go in the equation, but what it could do, if you didn't already know it, it could find the center for you, that the center is 5 units away. Notice that negative 3 plus 5, negative 8 plus 5 is negative 3, so they are 5 units apart. But I do have another formula on the ellipse. It's called the ABC relationship, that c squared equals a squared minus b squared. So let's write that down and solve. C squared has to equal a squared minus b squared. We're going to use our values. If c is 5, then c squared equals 25. So we'll say 25 equals our unknown a squared minus the b squared, which is 4. B squared we know is 4. I do my algebra, I'll add 1, and we find our a squared that we've been looking for. 29 equals a squared. So that would go here and be our solution to number 2. This parabola, or this, ellipse, if we were to draw it, what it would look like is it would be a little bit taller than the foci, and it would go from these points in here. So it looks something like that, give or take. Foci being the reflection points. All right, and now Number 3, it says write an equation. So here we are writing an equation again of a hyperbola. So I'm going to go to the formula chart and take the standard form. And again, everything but the y minus k's and the x minus h is what I'm copying. So I should have on the first fraction a parenthesis squared over a squared minus another squared over b squared equals 1. On this particular problem, they give me vertices. I'm going to stop. Vertices. What vocabulary term should you associate with vertices? 2a, 2b, or 2c? Vertices are 2a. So 2a are at 0, 0, the origin. That's a vertice. And 0, 4, 2, 3, 4. There's my other vertice. Okay, so 2a, let's make this connection in our brains. 2a is moving vertically. That means for the equation, the a part, the a portion, the a fraction is going to move vertically. So this needs the y minus k. This fraction needs the x minus h, because it's the a value that's moving vertically. We could count the distance. This is the distance from 0 to 4. So how many units apart are they? 4. So 2a equals 4. What does 1a equal? 1a equals 2. We'll use that for the center. For the formula, we need to know that a squared would be 4. So a squared is 4. Okay, for the center will be 2 units either way from these vertices. So this is the center, and its location would be 0, 2. When you plug those in, remember inside lies. So it'll be the y will be minus 2 because we're going up 2. The x, or the h rather, will be a 0. Now let's think about this. I'm going to use different numbers for a second. What if this was 10 minus 0? What is 10 minus 0? 10. 5 minus 0? 5. What's x minus 0 going to be? X. So you could actually just clean this up and make it just say x squared. All right, the only thing left is this asymptote. Now, asymptotes are very helpful. They come from the formula chart. So if you go to the formula chart, the asymptote is shown in point slope form. What I want to show you is, if you note, one formula has b divided by a, the other one has a divided by b. You could check and say, okay, we're dealing with the equation that has y written as the front end of the first fraction, the positive fraction. So it's going to be a divided by b. Or you could think of it in terms of rise and run and say, okay, this is saying that my asymptotes are going to have a rise of 2 divided by a run of 3, if that makes sense. We already know that the y value was 2 squared. 2 squared. So that just means the b value here, let me write it the way the formula chart now shows you, is going to equal 3. So 3 squared would be 9. And this would be our equation. Now, I got to tell you one thing that can be a little confusing, though. Let's just pretend, for the sake of argument, that a was actually equal to 8 from right here. Let's say we had an a that equaled 8. And then you come to this part, and it says a equals 2. What that would mean for the fraction is that the fraction would be reduced. So you might see that where we know a is 8, but then you see something where it says, and then we're looking for b, but you have something that says, well, it should be 2/3. What that would mean is it would be reduced and say, okay, what number, 8 divided by what gives you 2? 4. And so it'd be 3 times 4. You'd find out that the number would have to be 12 for b in that case. So I was just making that up on the fly, but I just want to point that out, that that will occur some points in time, okay? So with that, we have done our bell ringer, and it's time to start lesson 7.